Okay, we're going in deep, y'all. Enjoy a minute of music as you soak into the energies of today. And yeah, link to the music in the description below. Quentin Cash Band, Western Whiskey Train. We'll talk numbers in just a minute. Before you ask me why. Okay, so that's what we're doing, is we're trying to find some answers here. No better way than to share some pattern recognition software that has just come to my attention after 2 years of sitting on a hard drive. So one of the purposes of this video is to find the individual who taught me this information, because it's really not mine. I'm just trying to present it and investigate it and look at it, because that's what I do. I enjoy doing that kind of thing. And ultimately, I'd like to try to bring people together that have a very unique mind and see what we can do as a team. Looks like 2021 is going to be the year to do that. Probably a little late, but things happen the way they happen, and we respond however, I guess, the spirit leads us to respond. So the first thing I just want to mention is this number pattern you see at the top of the page. I came up with that in a dream, actually. So I just woke up one morning and remembered my dream, and that was there in my headspace. And then about, 3 or 4 months later, I found a mathematician online who had that in the banner of his website. And I had since, lost track of that site and that individual. So, I don't know. I'd like to give that guy a virtual high five, whoever he is. And then whoever the individual that came up with this prime number pattern, I'd like to try to track them down as well. So this video is actually inspired by a great number of people, and really this is just the kind of introductory video. I'm trying to get comfortable with this process. So if my technology will cooperate, we'll get a move on here. So the first thing I want to point out is this little device down here. We've got 2 equilateral triangles, and then we have 2 central points. So we've got 3 points to each equilateral triangle, and then we have the central points here, which brings us to 8. So 9 is an interesting number. So what we're doing in today's plan or lesson or class or demonstration is we're looking at the 9s. The feminine versus the masculine. We're going to kind of bring both those worlds together today. But, let's see. If you add 9 to 9, you get 18. And then you add the 1 and the 8, and you get 9. So what we do, 9 is this kind of like cycling, self-reflective energy. 9 stays 9. And also you can do it with multiplication. 9 times 9 is 81. 81. 8 plus 1 is 9. So what you're left with is 8 numbers. And you'll notice that the 8 and the 1 add to 9, the 7 and the 2 add to 9, the 6 and the 3 add to 9, and the 5 and the 4 add to 9. What does this have to do with primes? Well, the first thing I want to show you here is the family number groups as they relate to this. So we've got the 417 family number group here, 417, and we have the 5, 8, 2, and the 8 and the 1 add to 9, the 2 and the 7 add to 9, the 4 and the 5 add to 9, and the 6 and the 3 add to 9. And so what this does is this actually folds up so that you can do a translation. 8 plus 1 is 9, or 5 plus 4 is 9, or 2 plus 7 is 9. And the cool thing about this is the 3 plus the 6 is 9. So those are the 3 family number groups. And we're back to our question, how does this apply to primes? Well, within the 3, 6, 9 number group, there are no primes. So all primes fall within these categories. So we're going to start there. We're going to pick a card, pick any card. But in this case, we're going to pick a prime, pick any prime, and then you want to pick a second prime that fulfills the other category. So in this case, let's just start with 5 and 7. Okay? So here's what we have here. We're going to do 2 examples. So 5 is a prime and 7 is a prime. You add those together, you get 12. You find the midpoint. 12 divided by 2 is 6. Then you add the 5, the 6, and the 7, which gives us 18, which brings us to 9. So here's a pattern within these 2 primes. The question is, does this pattern apply to all primes so long as they fulfill these family number groups? And it looks like it does, which is just blowing my mind. So the next example would be 199 and 179. 199 belongs to the 417 family number group because this adds to 19, which is 10, which adds to 1. Again, we're doing the decimal parity, or the digital root reduction. The 179 belongs to the 582 family group. So we have one family group and another family group. We add those together and you get 378. You divide 378 by 2, you get 189. Now you add that midpoint. This 189 is the midpoint between these 2. Now you add all 3 of them together and you get 567. And this is just a coincidence that I got 5, 6, 7 up here and 5, 6, 7 down here. I actually just randomly chose 2 primes that were in different family groups. So 5 plus 6 plus 7, 18 equals 9. So I'm just fascinated by that. And so what I've done here is I've listed the primes starting with 5. 1, 2, and 3 don't really work. So I think 5, and somebody can correct me if I'm wrong, but from my perspective, looking at this, 5 is the first prime. And then, so a dot to the right represents one family number group, and a dot to the left represents the other family number group, so that it lets me organize over here the family number groups. Remember, the midpoint is the 3, 6, and the 9. There are no primes along this middle line. The primes lie on these lines. And so what we've done here is we've taken the 5 in one number group, and we've taken the 7 in another number group. That's 12. You find the midpoint, which is 6. So you add the 5, the 6, and the 7, and you get 9. So this line right here, as you draw lines like this, I haven't actually done this yet, but I'm going to. So here's the same kind of thing, where the family number groups are listed at the top there, middle, and the bottom. So we've got 7. So the idea here is to draw a line from 7 to 5, obviously as straight as possible. And then in the middle, you've got 6 here in the middle. And then you do 7 to 11 over here. And then 8, 9, 10, 11. So 9 is the midpoint here. And then you draw a line from 7 to all the primes. And this equation, the math comes out like this. So if you pair 7 with 11, yeah, let's see, 18 divided by 2 is 9, so that's the midpoint. And you add those together, it's 27 equals 9. So 7 and 17 is 25, or 24, plus 12 is 36 equals 9. So you can do the math on that. Somehow this relates to the Riemann hypothesis. So, I'm here to learn as well. I want to understand if this prime number pattern is a geometrically lawful expression, and if a supercomputer could do some churning and burning on this concept. So, yeah, it's just me messing with it again. 369 number group doesn't have any primes. It's really interesting. So if I were to take, let's take, how far did I go with this? So we can literally take any number in here. Let's just start with 109, and let's match it with random number 137. That's a big number in physics and mathematics. Okay, so pull up my calculator to make this seamless. But 109 plus 137 is 246. 246. And then divide that by 2 and you have 1, 2, 3. That's cool. Okay, so we want to add 1, 2, 3. Plus 1, 2, 3 equals 369. That's cool. 369, which adds to 9. 9 and 9 is 18. 1 plus 8 is 9. So if you have any prime over here and any prime over here, you add them together. Then you divide by 2 to get the midpoint. Once you have the midpoint, you add up the 109, the 123, and the 137. You get 369 in this particular case. And if we understood the magnificence of 369, we would have a key to the universe, right? According to Tesla, apparently, I don't know. Just looking at the patterns. Can't argue with the pattern. So here's the math. And it applies. It looks like it applies across the board. So the geometrically lawful situation here, if you start to draw your lines, and then you take the 13 and you draw the 13 to the 5 and the 13 to the 11 and the 13 to the 17. Each number draws a ray, and then each ray is basically a ray of 9. So I'm just going to play with that a little bit more, and yeah, I'd love to have these kinds of discussions. I've got a lot more mathematical patterning to discuss in the next few episodes. So yeah, thanks for being here and thanks for listening. And this right here is just pretty fascinating. You just go down the line here. This is only using 7. This is connecting 7 in one of the family number groups to these numbers, which all of these numbers are in the other family number group. And without fail, this mathematical operation results in the 9s. So it's not turtles all the way down, it's 9s.